Okay, so I'm going to just go give you an overview of automobile manufacturing industry of any particular company. So this is just going to be an infographic, and I'm just going to give you a overview of the whole process. So how does a manufacturing begin, and how is the output car received? So we're just going to go through step by step. So in any automotive company, what you would see first is that they are purchasing steel. So maybe from any company like Tata Steels or Jindal Steels, they buy the steel, big steel rolls. They have it stamped in this, and the sheets are passed on to conveyor into the stamping building. So in any, if you go to any automotive plant, maybe Maruti, Hyundai, Renault, or Toyota, or any automotive plant, you will see a big building called as stamping. So first, what they will have stamping dies, fixtures, etc. So the stamped sheets will go in, and there will be this big stamping dies which will stamp it into the required shape of a door. For example, as you see here, at this stage, this is totally electronically controlled and totally managed computerized in a computerized manner. And once the stamping is done, you will get the required shape, but with sharp edges. At this stage, you will roll out the sharp edges, and this process is called hemming of edges. Again, there will be like minor punching of holes, etc., whatever is required, and that activity is done here. And once the edges are smooth, and the steel sheets are converted to the required steel shapes, okay, for say for example the door, or whatever of of the car. At this stage, this is from here there will be a quality control check, and this is the end of the stamping line. So this entire activity is called stamping, and you will see a separate building for this in any automotive plant. From the stamping plant, all those stamped different components, maybe doors, a hood, etc., everything goes into a different line. This line is called the body in white line. So in this line, they will take up those stamped parts, and they will have robotic welding without human intervention. So there are huge robots which cannot be moved around that easily. So they are fixed in at places, and they have defined programs to operate this. And once these parts are available, they are welded together to arrive at welded together using robot. So some parts are still not welded robotically, like some complex parts which you cannot be reached or something, and then there are semi-automated welding with handheld weld guns for smaller parts. So once the left and right side of the car are assembled, then it goes to the roof placement, and again a robotic welding happens, and the roof is also welded together. At this stage, this is called a body in white. This entire shell of the car is called the body in white. And here again you will have quality control. So there will be a chamber with tube lights all around, and people will be employed to check the quality of the whole body. And if it is successful, it will move further, or it will be rejected at this the body will be rejected at this stage itself. From here further, it moves into what is called as the paint shop. So this whole part is called the body shop. So you have covered the stamping shop, the body shop, and now it goes to the paint shop. In the paint shop, first it is continuously dipped through three different tankers. You like, it could be different also in different new processes are also available, but basically degreasing will remove all the dirt or anything, or any other like welding residue or that was there on the car. So degreasing, then there is a primer application, then an electrolyte dipping also happens, so that this helps for your anti-corrosion coating. After all these three dips, it goes to the anti-corrosion coating. So this is a coating done to prevent it from corroding or like from rusting. And then it moves towards the paint shop. So you have robotic as well as manual spray painting that happens on the car body. And after this, it goes into the dryer, or with your infrared lamps. So at this stage, it is dried, and the car comes out of the paint shop. So in the next light tunnel, the paint quality is also checked, and otherwise it will be removed from the line and rework will happen on this. So at this stage, you can say that the body in white is painted and it is ready. And now it will move towards the trims and chassis line. So at this stage, the first activity that happens in the trims and chassis line is to remove the doors for easy access, and then it is mounted on the powertrain. So the powertrain will arrive separately from the powertrain line or from the powertrain plant, and it is mounted on this powertrain. This process is called marriage. It could be an IC engine or an electrical vehicle nowadays. but this process is still called a marriage. And once that happens, after the marriage, there are a lot of sequence of application processes that happen here. So there are more than 100 different operations that have to happen here, which involves assembly of all of the different components that you see in the cars. So there are thousands of components that go into a car, right? Like, so different sub assemblies, different systems, so that have to be completed. Like, for example, your brakes, your suspension, your steering, your dashboard, your seats, boot, and all the plastics and all the electrical components, bulbs, etc., headlamp, etc. So many different components that have to go into the car, they are assembled here, some of them robotically, some of them manually. And all the tools and gauges that are required have to reach just in time. So just in time means when they are fitting the tire at that location, the screwdriver should be there at that particular location with the resource who is the person who is doing that. So for enabling this, there are moving chairs and conveyor belts, and parts are assembled with fasteners, sealants, adhesives, etc. Okay, so this is the whole automotive manufacturing cycle. And at the end, there is QA checks, also some electrical, brakes, wheel alignment, suspension, headlight. All of these are checked at this. Cars are rain tested in rain chambers, etc., and finally delivered out of the plant. So this is the whole overview of automotive manufacturing. I hope this was interesting. Next up, we will go into bill of materials and bill of processes. So we already discussed about engineering bill of materials. What is manufacturing bill of materials? So along with EBOM engineering bill of materials, you have a parallel stuff called manufacturing bill of materials. This includes the stuff that is required apart from the parts to manufacture. It could be like your sealants, or it could be like your component materials like grease, or whatever that is additionally required on top of engineering bill of materials. Also, there could be end items. What do I mean by end items? Like, for example, if a company like Maruti is manufacturing a car, would it manufacture this for each and every component in the car? No, it does not. Like, for example, you will have your spark plug that goes on the engine. They don't manufacture that. They purchase it from Bosch or any other different company. So there are a lot of different fittings that go in the car, different parts that go in the car, which the company purchases. It does not manufacture. So that, but it would design also. It would design, and it would supply to. It will ask a supplier to manufacture it for them. So that becomes what is called as the end item. So a filtered list of the bill of material, where the sub assemblies are not taken care of because it is taken care of by the supplier, and any additional object that is required to manufacture is called the manufacturing bill of materials. There are also service bill of materials, which is required by the service centers to service the product. And then there is something called the bill of processes. So what is bill of processes? It is the list of operations. Simple. So it just means, how are you going to do this activity? How are you going to fit the tire of the car on the wheel? How are you going to fit the steering wheel? So all of those are operations. Each operation can have different activities that go under the operation. Like, okay, lift the screwdriver, walk 2 steps, lift the wheel, fix it on the car. So these are all different activities that can go in a single operation called wheel fitment. So what are work instructions? As I said, different activities and different positioning that needs to be done, which are parts of an operation, are listed down very carefully, and animated and images are taken. Animated images of that process are taken, and these are called work instructions. Again, to talk about takt time and jobs per hour, JPH, jobs per hour, these are factors that determine how the processes have to be streamlined, so that the process happens quickly. Jobs per hour is simple, but like, how many jobs are you able to do, how many cars are you able to produce in an hour. Takt time is the total time available divided by the total demand that you are having for this on that particular day for the plant. So these are things that you keep in mind while fine tuning your list of operations. And then there is time analysis, and there is something called most code. Most is Maynard operation sequence timing. Why do you do time analysis? You do time analysis because you should know exactly, like, how much time it takes to fit the wheel on the axle, or like to fit the headlamp, how much time it takes for each and every activity. And what is the difference if that activity is done by a robot, or by a human being, or by using a lady resource or a man resource. All of these kind of studies are done, and the whole time is arrived at, the whole cycle time is arrived. So this is what is a bill of processes. And finally, you have bill of resources. What are resources? Resources are anything that help you to manufacture. Anything that helps you to manufacture is the resource. So there is something called what resource, where resource, and who resource. What resource is like, what do you like, for example, what do you use to manufacture? Like, for example, it can be a weld gun, or it can be a screwdriver, or it can be a spanner. So these are called what resource. What are where resource? So simple, where are you going to manufacture? In on an assembly line? Okay, on where is this resource going to be available? On a conveyor belt, or on a moving vehicle, or something like that? Where would you get this resource? Or like, where do you plan to do this activity? All of those things goes under where resource. And then you have who resources. Who resource, simple, but is it going to be a robot? Is it going to be a human? Is it going to be which kind of human from which citizen, what race? Because everybody's height, weight, and their capacity to work is different and documented, and their timing is planned. So these are the different kind of resources that you have in a automotive company. Okay, now we are going to PPR context. PPR context is product, process, resources. Okay, it's a context in which you are going to link up all these three, whatever we discussed till now. It is a placeholder for your engineering bill of materials, manufacturing bill of materials, bill of processes, and resources. What does it help you to do? It helps you to plan, establish, and create the link between different the digital design, whatever digital design you are having, and the manufacturing data what you are having, whatever operations you are planning to manufacture that, and the manufacturing bill of materials that you are having, to create the link, so that you know which operation is done for what product, and where you are doing using what tool. So all of that is planned using the PPR context. It also helps you to simulate the manufacturability. So like, for example, is it possible to do it at that point, at that place, using this tool? Is it possible? So we have to simulate and see. We have to see the sequence of machining. We have to see if the ergonomics, or like by ergonomics I mean, whatever activity is planned, is it humanly possible? Can a man reach there with his hand? Is it visible? Where he wants to do that activity, that particular point, is it visible? Is the hand reachability there? These kind of studies are done in the ergonomics of manufacturing. And finally, it enables you to do the time studies. So this whole thing is called the PPR context. And finally, it helps you to publish all these instructions, whatever planning and whatever simulation you have done, and whatever optimizing of the process planning that you did. It enables you to publish this to the manufacturing plant. So now we are going to see how MBOM can be generated from the EBOM using Delmia. So what you see on the top is called the EBOM tree structure, and now you have a parallel manufacturing bill of material tree structure that you're going to create. So first you have a root node, and that red symbol shows that this manufacturing bill of material is going to be linked, scope linked directly to this engineering bill of materials. So this is going to be the root MBOM for this. And now we are going to drag and drop different EBOM elements. So you have manufacturing assembly. So this is an MBOM object. So this is going to be an MBOM object, and we are going to drag and drop objects and from EBOM and assign it to the MBOM. So the motor is now getting assigned, and now the parallel MBOM for that EBOM is generated. So you would see that there is only one node under it. And what is the difference between the properties that goes on the MBOM? So when you do properties on the MBOM, you will see what is the time, what is the cost of that product, what is the lead time that it will take. Lead time is like, once you order that particular product, like say engine, if a car company is buying engine from another company, how much time it will take for that company to deliver it. So all of those things goes under the MBOM properties. Also, you would see something called is end item declaration, or like, is it an outsourced product or it's an in-house product? Are we manufacturing it or are we buying it? These kind of decisions are also done there. So if you see on a provide, you that is on an MBOM node, you will see all these properties being defined. What is the material, and so on and so forth, like from what date it was in production, and from what was the parent production, and so on. So what is the release date? So you can set all of these properties under it. Basically, MBOM declaration means that which product you are going to buy, which product you are going to manufacture, when you can get it, what is the cost involved, what is the time involved. These are factors that that go into the MBOM. These processes can parallelly be done also in the in the ERP and MES system also. Okay, so you see that there is an attribute here called outsourced. So the see outsourced, yes, and planning required, no. What does that mean? It means that you don't need to plan for the manufacture of this, because we are going to buy it, or we are going to outsource it to a different company. So these are all different attributes that are available on MBOM. Now we are moving to process planning. So once you have the manufacturing bill of materials, we can do the process plan. So I'm going to describe how a process plan structure is created. So within the PPR context, you have the engineering bill of materials and you have the manufacturing bill of materials. Now we are going to define the process tree, where you will see that the assembly plant is planned. Now let's say you are going to manufacture it in one particular plant. This plant can be like in Chennai or in Gurgaon or wherever. So where is the plant? So that plant's name you will define, and inside that plant you will have different things. Like for example, you will have a building inside the plant, or you will have an assembly line inside the plant. So if you have a different line buildings to be defined, you can define buildings also. Inside that, you're defining different assembly lines, and in the assembly line you could have multiple assembly lines, and in the assembly lines you're going to define stations. Stations is where some activity is actually done. So whatever the manufacturing activity is done, so you can define different stations inside the plant. So again, so this is a process of defining different stations. So obviously one assembly line will have multiple stations, and maybe like multiple stations, which will be where there'll be a product flow. So the output of one station will go as input to the next station. We are creating multiple stations here. And now at this stage, we are going through the process called scoping. So we will say that this particular embalm, this whatever embalm was created here, we are going to manufacture in this plant. So what we do is called creating a scope. So once we scope it, we say that this entire embalm we have allocated to this particular plant. So you will see a blue circle. It indicates that a scope is created. So it says scope creation successful between plant and embalm. Once the entire thing is allocated, you can drag and drop, or you have using this tool called assignment manager. What you can do is you can assign different embalm to different stations. As you see, so the one particular embalm was assigned to station 1. The next embalm I am assigning to station 2, and say equipment I assigned to station 2, chassis I assigned to station 3. So once you have this assignments done, you see multiple levels of assignment, multiple products are assigned to multiple stations. But that is not enough. You need to define what is called as the product flow. So from which station what material goes to the next station, this is this has to be defined. You have something called the product flow. So you say station 1's product will go as input to station 2, station 2's output will go as input to station 3, and so on. So whatever I'm trying to show is very simplistic. So at this stage, you see station 3's output image has totally changed. It is an assembly of all the parts that we have got till now. So right. So this is how we move forward. So station 1 to station 2 to station 3, once we have defined the product flow, we know, okay, at the end of the assembly line, the whole assembly line, this is the output. So what you see in the actual colors, the bold colors is the output of that, and the translucent color, the transparent translucent part is the whole car. So when you click the plant, you see what is already up planned for. Whatever is thick, whatever is the opaque colors that you see is the parts that you have already planned for. The translucent are remaining, and you have planned the plant the particular assembly line. So this entire process is called as process planning. From here on, so we have come to the end of this discussion about the introduction to process planning. From here on, what else is the possibility? The possibilities are endless. You have a lot of different roles and different apps to explore there in that compass. As you saw in the first, in the initial slide itself, there are a lot of different options available inside that, and you could do simulations to see if the assembly actually can happen smoothly. If something will collide, will two parts sit together, or like say the resource, the screwdriver, will it reach that particular screw? Can the human being actually place it? So for that, you have what is called as a mannequin simulation. So where you can actually place a human being here and try to see if his hand is reaching there, his screwdriver is reaching there or not. Those kind of simulations you can do. you could do clash and contact simulations, so that in the automotive industry there are different standards saying that no, you cannot place something very close to each other, like say 5 distance has to be maintained between two particular parts. So those kind of things you can analyze, you can learn about different stuff like how to create product flows, how to streamline your product flow, how to create your then you will you can see what is called as a Gantt chart. What is a Gantt chart? Gantt chart is helps you to see what is the time taken for each operation under each station, and how that each operation can be defined, each activity can be defined, what is the time taken for each of them, what is the most code for each of them. That level of detailed planning can be done. What I have shown you is a very very macro overview. There is a lot of things that you can learn in if you go in depth to it. There is like workload balancing, so that maybe like the resource is not too much stressed also, so that you can have multiple resources, and what is the usage of each premise, each assembly line, and so on. There are a lot of planning options inside this. And this is just an introduction to a process planning as such. So we are just trying to do it with a toy right now, but in the actual real case there is so much more complexity involved. So I hope this was a good learning experience for you, and good knowledge that you would have gained, and how digitally things are done, that it would have you would have got some enlightenment on that. Just going to give you an overview on what are the different job profiles in the industry, in the automotive world, in the aerospace world for this. So there are obviously a huge demand for design engineers. Design engineers are people who design the CAD using the geometrical constraints what are given to them from the vehicle architecture, from the architecture team and the styling team. So there are a lot of openings on design engineers for a lot of companies in different departments. So definitely CATIA is a big skill set for design engineers. Parallel software are also called NX from Siemens is also a parallel software, which will if you have knowledge, it is good. There is again process planning that we discussed till now, Delmia. So you have openings for process planners in all the automotive and aerospace OEMs. All the automotive OEMs, definitely they will have, not only OEMs, even tier 2 suppliers with complex manufacturing practices like Bosch or like Micro and a lot of tier 2 suppliers, they will also have openings. Simulation engineers to simulate and see what is the stress, strain, heat simulations, what are the assembly conditions, clearance checks, so on. This is a big activity that happens, and most of them, and these activities, mind you, are also happening in services companies like Infosys and TCS and Tata Tech Mahindra, etc., because they take up a lot of these activities outsourced from the whole world, and they try to do it as offshore in India. So there are a lot of openings for all these, majorly all these three. You will see a lot of opening that is happening. Industrial plant layout designers, little less than compared to all the other three, because plant layout is not something that you would design daily. It is something, product design is something that you do daily. Plant layout is a little less. Plus it is a little bit oriented towards, it's somewhere between civil as well as mechanical engineering. So you will see those kind of openings also. There is always a demand for machining engineers, people who can write CNC code and simulate that, because again 3D experience allows you to write CNC code, or like even if you can't write even if not only writing CNC code, to simulate the CNC and generate the CNC code, stuff like that. So there are openings, there are a lot of profiles on those domains as well. And then if you get into the world of manufacturing execution, and if you're a person who wants to really work on the plant and see it live, there are, if you know MES and if you know ERP systems, you can get openings in the manufacturing plant also. So there are this learning virtual manufacturing is really going to add value to all kind of engineering background people. So it's a win-win situation. So definitely choose your niche and learn get onto some part of virtual manufacturing is what I would have to say. So I hope it was a informative session for all of you, and I look forward for your feedback. Thank you.